Okay, so we've got starter, evaluating the response, saving that evaluation, whether it's correct or incorrect, into the data file, and giving feedback on each trial. Boy, feedback, that was kind of a pain in the neck, and I made quite a few errors in the in doing the video to code that thing. Of course, I made a lot of errors when I was actually coding it too that I had to go back and repair. Now, what I'm going to introduce at this point, it's very convenient now that we have this evaluation of each trial, whether it's correct or incorrect. It's now a good time to introduce you to the idea of an adaptive procedure or a staircase procedure, where you're going to change the variable in response to the participant's behavior. And in particular, what we're going to staircase here, well, we're actually not going to do a staircase here. We're just going to do an adaptation where, well, I guess you could call it a staircase. We're going to make the stimulus dimmer or brighter depending on whether they were correct or incorrect. So if they're correct, then they're getting plenty of information to do the task. So we're going to make it a little dimmer. Actually, we're going to make it a lot dimmer because I want it to be visually obvious what's happening. In a real experiment, you would probably just incrementally make it a little bit dimmer as they were more and more correct. And if they're incorrect, if they emit an error, then we're going to make it brighter because obviously they're not getting enough information then in that case to do the task. Now again, we have a ridiculously simple task. The purpose here is to teach you to program, not to actually conduct science. The science will come later, but for this very ridiculously simple thing, we're showing a red or a green circle. We're just going to make those circles brighter or dimmer depending on whether the participant is correct or incorrect. All right, and so starting with our starter, the first thing we need to do is add a variable. What we're going to do is change the target color intensity, which let me just come down here to trial and remind you of how that is set, where that is. So here's our trial function, and we have an Allegro color, the circle color. And if our target color was green, then we're going to map the RGB 0, 255, 0. And that's the number we're talking about right there. And if it's red, then it comes here. RGB, remember, red, green, blue. And this first one is red for the red maps. The middle one is green for the green targets. And that's where we're setting the intensity of the color value. So we want to change that to a parameter that changes, or a variable that changes, depending on whether the participant was correct or incorrect in their responses. So up here in main, we need to, right here in our integers, where we're declaring all of our integers, we need to add target underscore intensity to the list. And this one is not a array, so it's just a single value. Let me return here to put it on the next line so we can still see everything. Oh, and when we define it, let's go ahead and set it. We're going to set it at 150. 150 to start. So these numbers can range from 0 to 255. Let's start it in the middle, and then if we get correct responses, we'll make it a little dimmer, and if we get incorrect responses, we'll make it a little brighter. Okay? Now we need to pass that intensity value to trial. We need to tell trial what intensity we want to use. So this is an int, an integer, and we'll just keep the same name. A lot of coders will tell you never ever do this. Never use the same name in two different functions. But I often do, especially when I'm passing a variable from one function to the next. I could change the name here. I could call it circle intensity or circle brightness or target brightness, or I could use a different variable name here than I'm using in main. I guess that can sometimes cause problems. If a professional programmer tells you it can sometimes cause problems, they probably know better than I do, because they do this 10, 15 hours a day, 6 or 7 days a week. I do not do that. I program when I need to, and then I don't program when I don't need to. So they probably have a lot more experience, but I've never had problems with it, and to me it makes sense to make my code readable to keep that variable name the same. Also, what makes sense is to not forget to put this is the function prototype here. Let's not forget to put it in the actual function declaration. Oops, there's trial right there, comma, and paste. There we go. All right, and then when we actually call the trials, we now need to pass target intensity to them. And now that should work. Okay, so let's go ahead and make sure we haven't introduced any errors into our programs yet. We're going to go ahead and run it now. And what we should see are the same circles that we were seeing before, except they should look dimmer now because we have, oh no, wait, they're not going to yet. Wait a minute. So we're now passing target intensity into trial. And what have I forgotten? I forgot to replace it here. So where we actually set the circle colors, the target colors, this is where we need to replace the numbers there with these intensity values. So instead of 0, 255, 0, it's 0 target intensity 0. And obviously, you could control each of these three numbers independently. We could put target intensity for all three numbers, and that would give us a grayscale, and we could change the intensity of that grayscale by changing all three numbers at once. You can do all these sorts of things. It just depends on the situation you're in. For right now, we're just going to change the intensity of whatever the primary color is of the target. Now I believe I've done everything that I need to do to make this work. Let's run it and see if we have any errors. Then I'm going to stop this video and pretend I didn't make those errors. Nope. Aha. Yep. So now you can see that we get the same stimuli we got. Oops. We get the same stimuli we got before, but just not as bright as they were before. So if you go back to the earlier videos on this stuff, you'll see that this is not quite as bright a color as it was before. All right, so far so good, but nothing's adapting yet, right? So now what we need to do in order to make this adapt is up here in the for loop that actually calls our trials. After we get an evaluation of the accuracy on each trial, whoa, where did I stick that? What did I do? Okay, we need to come, oh yeah, that's in the right place, right there. Right after we get an evaluation returned from the function eval response, we want to use that evaluation now to change the color. And of course, we're going to do that with a conditional statement, an if statement. If the trial accuracy, trial ac, on that trial, so the ith trial accuracy, equals 0. Remember, 0 means an error. 1 means it was correct. I really should do a pound define and define those values so we can start using those words, correct and error, in the code, but I've been too lazy to do it so far. Okay, we'll do it before it's all over with. By the time starter is finished, it will be immaculate and beautiful. All right, else if trial ac I equals 1, that means it was a correct trial. And of course, we have our curly brackets. So now inside the curly brackets, what do we want to do? Well, let's start by changing the target intensity. Now, if it's an inaccurate response, that means maybe this stimulus was a little bit too dim. They weren't seeing it very well. So let's have the target intensity go up. And let's do it by a big amount. This is probably ridiculously big for a real experiment, but I want it to be visually obvious what has happened here. So we're going to add 50 to the starting value of 150. So the first time there's an error, it's going to go up to 200 right off the bat. The next time there's an error, it's going to go up to 250 right off the bat. And now I am just going to copy this because we want to do something very similar down here, except instead of plus 50, if we get a correct response, we want to subtract 50 and make it even dimmer. So, I go into the book why you would ever want to do a staircase procedure, an adaptive procedure like this, and so I won't belabor it here, so I won't make the video too long. But this is a way of efficiently sampling from a part of a person's performance profile that you want to get the most data from, and to get there very quickly and efficiently without wasting a lot of time at the ceiling where they're performing perfectly, or at the floor where they can't do the task at all. Okay. So now this should work, but it's not going to work perfectly. But I want to stop here and run it because I want you to see what happens. And if you're doing this yourself at home, go ahead and run now and see what happens. I'm going to pull this over. Yep, there we go. Okay, so we had an error. It's going to get dimmer. That was correct. It should get brighter. I'm just going to go with errors, and it should get not getting dimmer. Oh, there it got dimmer. Okay, visibly dimmer. Aha, but now you see it's getting brighter again. So what's happening? And this was exactly what I was talking about. Why is that happening? I wasn't responding at all, so every response was evaluated in error, and it got dimmer a little bit, and then it started getting brighter again. So what's going on? Well, remember from earlier in the book, if you're reading the book, and if not, I probably mentioned this in an earlier video. I don't remember, but maybe. The numbers are intensity numbers for all map RGB, the ones that go 0 to 255. If I put in a number that's outside that range, it does not return an error for that function. Instead, it just rolls the number over. So for example, 256 here in this slot, or in this slot, any of these slots, 256 would be read by the compiler as 0. And 257 would be read as 1, and so on. So in other words, it just remaps bigger numbers onto that 0 to 255 range. So up here, the first time we have an error, it takes away 50, and we go from 150 down to 100. Second error goes down to 50. Third error goes down to 0. You wouldn't be able to see the target at all. The fourth error is now going to go down to negative 50, and that's going to get remapped to some very bright value. So I guess I'm just doing the math in my head. I think that would be 205, right? Or 206, something like that. So anyway, it's just going to remap. It's not going to keep it at 0 or keep it at 255. So we need to put something in that will keep it that way. Now, in the book, I go through a couple of different ways to solve that problem. Oh, and I should say this here in the video too. You should stop the video now if you're just doing this in video, or if you're doing this in conjunction with the book. Stop now and try it yourself. Try to put in a contingency so that these numbers don't grow beyond 255 in the case of being added to, or below 0 in the case of being subtracted from, so that we stay in that range 0 to 255 no matter what. So if we get a range of errors, if we get a series of errors, it should never get brighter than 255. And if we get a range of or a series of correct responses, it should never get dimmer than, I would set a floor at about, I would say 50. 50 is probably the floor that you want to set. Never make it dimmer than 50, just for purposes of this program. Obviously, if you were doing research, you might actually want it to go down to where it's not showing the stimulus at all. I don't know why you would do that, but it could happen. I can't necessarily think in my head about all possible experiments that people would ever want to do. So you might want to do that, but for now, let's just keep the floor at 50. So stop the video, try it on your own, and then come back here for the solution if you don't solve it. And in the book, I give 2 different solutions. All right, so did you stop the video? You didn't stop the video, did you? You're just going on, and you're going to let me give you the solution. Lazy. You're not going to learn to program this way. All right, if you did stop it, good for you. All right, let's go on. So the solution to this problem is we need another condition in both of these conditionals. You could actually nest another if statement down here. I show that solution in the book, but a more elegant solution is the multiple conditions conditional. So the double ampersand is and to C or C++. And so I can also say only do this for an incorrect response so long as the target intensity is, let me think about this one, less than 249, let's say. No, let's say 201. 201. Now, why 201? I only want you to add 50 if the intensity is less than 201. Well, if we're getting intensities added because of a series of errors, we're going to go from 150 to 200, and then from 200 to 250. And then as soon as we get to 250, we're going to roll over. We're going to, the intensity values are going to roll over to the less intense values. So I want only when we get up to 200, I want to add 50 one more time to get up to 250, and then I don't want to add any more intensity value to the stimulus. So I need to set the threshold here at 201 because I do want it to reach 200. If I said while it's less than 200, I would only reach 200 and stop there. So I go one above that, 201, and now once I hit to 200, I get one more addition of 50, and it won't add 50 anymore after that. And then down here, I don't want to go below, so as long as target intensity is greater than 50, I want to keep taking 50s away. So I'll go at 150, that'll be true, so I'll go down to 100. At 100, it'll be true, so I'll go down to 50. But once I hit 50, I am no longer greater than 50, so it'll stop taking away intensity values. Okay, so let's give that a shot, see if it works. Oh, didn't drag it over in time. Hang on. There we go. Yeah. Correct. There we go. Correct. So now it should start making it dimmer as long as I respond properly, but it should only get so dim. Yeah, and so that should be the bottom. Okay, there maybe weren't enough trials to illustrate that, but it worked. It never got dimmer than 50, and it will never get brighter than 255. Okay, that's it for this video, and I can't believe it was actually 15 minutes. I thought this one was going to be a quick one. It's actually almost 16 minutes, so I'm going to stop here. I've been rambling long enough.